Thank you for Chairman introducing me. I'm Mitsuru Hosoda from Railway Technical Research Institute in Japan. So my presentation title is Study on the Prediction Method and the Tendency of Transverse Crack Propagation of Heat-treated rail based on rail bending test and compact tension test results. So let me start with background. So, rolling contact fatigue is occurring by the repeated running train. It causes horizontal at first, and it branches the transverse crack, and sometimes it leads to the rail break. And for the timely maintenance period, such as replacement and inspection, so to investigate for the transverse crack rate is necessary. So, however, it's still unclear which factors affect strongly to the transverse crack rate. So, factors means radial stress and heat-treated, something like that. And also, in Japan, so gauge corner crack is occurring. So, this crack is more dangerous than usual transverse crack, we believe, because transverse crack angle is more vertical. And so this crack is occurring at heat-treated rail and high rail in curve in Japan. So to investigate transverse crack rate, we conducted mainly three tests, two tests and one measurement. At first, we conduct CT test. It means element test taken from railhead to investigate the effect of heat treat and stress ratio. And second, we conduct the transverse crack test to, it means bending test for real rail. To evaluate for the radial stress and crack position for transverse crack propagation. And third, we measure the radial stress inside the railhead in order to investigate for distribution of radial stress and analyzation the cause for the result of transverse crack test. So let's start with the CT test. So the figure on the right shows the test method. We took the test specimen from railhead, and the direction is horizontal and also vertical. So we evaluate for the direction, and also to evaluate the heat treat, we took the shallow position and deep position. The figure on the right shows the test result, and the horizontal axis is effective stress intensity factor, and the vertical axis is crack growth rate. So, and we conducted 4 test conditions, and if we look at the stress ratio 0.1, these tendencies are also same. Although we conducted 3 tests. 3 tests is a different condition, and heat treat and non-heat treat, and the horizontal and vertical. So 3 conditions are different, but if we look at stress ratio 0.1, this test is almost same tendency. It means effect of heat treat and direction and depth are small. And also, if we look at stress ratio 0.5, it means the stress ratio will be bigger as the propagation rate will be higher. Next is transverse crack propagation test. We put the rail upside down with on the rail rack, and we put the artificial crack to railhead, and we apply the vertical load to generate tensile stress in railhead. And this is the simple stress condition to evaluate the effect factor for transverse crack propagation. And the table on the right shows the test condition. Especially, we prepare various rail, and especially we prepare the different rail type, such as heat-treated and non-heat-treated. And also we prepare the anneal rail. It means to evaluate the anneal effect. Anneal is for the reducing residual stress. And to evaluate position crack. So we prepare the two kind of specimens. One is the center and the other is eccentric. This slide shows the test result. The figure on the left shows the different type of rail type. And the horizontal axis is the number of loading cycle, and the vertical axis is the depth of transverse crack. This graph means although two different rail types we conducted tests, but the effect of heat, it is almost same tendency, which means the effect of heat treat is small. Next, the figure on the right shows the effect of residual stress. So gray point is shows the result of anneal rail. So the tendency is low compared to the usual rail. And it means the residual stress strongly affects the transverse crack rate. Next slide is evaluation for the crack position, different crack position. Specimen is center crack. We put the axial crack center and eccentric. So, and the right figure shows the result. So if we look at the blue plot, its result is center, and red plot is eccentric. So this figure means if we look at the eccentric, so the break is occurring in shallow position. And as you can see the picture, so we look at eccentric, so it causes shallow position. Yeah, it means a specimen with eccentric block on shallow position. Third, we measure the residual stress for evaluate effect of the residual stress to transverse crack rate. This method is relatively new. This method is we put the hole to railhead, and then we measure the diameter from top to depth, from top to 5 millimeter, and using the air probe. And so after that, we process a hole again, so measure the diameter before and after process. The figure on the right shows the result of measurement. Horizontal axis is the residual stress. Vertical axis is depth from rail top. This graph means we conducted two different type of rail, but the measurement result is almost same. We look at from 20 and to 30 depths. So it's almost the same value, like 100 Newton per milli square. This means the reason is that it is not significant difference on transverse crack rate on the test. Next slide is traditional method to measure the radial stress. We insert the strain gauge to railhead, and after that to cut the short size. And the result shows the radial stress almost was revealed. This specimen is for the annealed rail, because we want to check the effect of anneal by cutting method. So radial stress almost was revealed inside, and surface is almost 50 Newton per meter square. This means the reason that it is different between annealed and non-annealed rail on transverse crack test. Finally, I would like to conclude investigated the effect of rail type and stress ratio for crack propagation by CT test, and also investigated the effect of the radial stress and the crack position for transverse crack propagation rate by transverse crack propagation test using railroads. Regarding transverse crack growth rate in railhead, the effect of heat treat is small and radial stress is big. The crack portion affects depth of crack. So in my paper, we estimated the transverse crack rate using a theoretical method, but the time is limited. So if we are interested, please see my document. Thank you for attention.